Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science, MLR Institute of Technology, Hyderabad. I welcome you all with another video on stream processing and analytics. My today's topic is stream processing models. So we'll go into the topic. So the overview of presentation involves two parts. The first part is stream processing model, and in that there are three subparts, and as a second topic we are going to learn about immutable streams. So what are these two topics we are going to learn in deep. So as a part of our first topic, now I'm going to explain you about stream processing models. So what is a stream processing model? Stream processing model is a data management technique. Okay, we can say that stream processing is a data management technique that involves ingesting a continuous data streams. As name suggests, that stream is nothing but a continuous flow of data. Okay, a continuous flow of data. So dealing such kind of continuous flow of data is nothing but stream processing. So we can say that it is a technique ingesting a continuous data stream from a data source to quickly analyze, filter, transform and enhance the data in real time. So in real time we are going to deal with the data as in a continuous form. So after getting the data, we have to do analysis and then filter and have to apply transformation functions to enhance the data in real time. So data sources for stream processing can include transactions, stock feeds, website analytics, connected devices, operational databases and weather reports and others. So here, as a part of stream processing, we are going to involve three steps. Okay, so stream processing works in three stages. So here the first step is nothing but data source. Okay, here you can see data source, and in the middle one it is a stream processing engine. Okay, in the middle, and the last one is data sink. So if we compare this stream processing with a normal traditional process, if we want to analyze any data, we'll follow normal three steps, right? What are those three steps? The first one is collecting the input and applying some transformation functions or any other analytics, and then collecting the output as a result. So if we compare this normal traditional processing with the stream processing, both are similar, but the terminology changes when comparing with the input output. So here, as an input, here in stream processing we are calling it as data source. As an output we are calling it as data sink. In the middle, stream processing engine will work as a data analysis engine. Okay, so we can almost combine these two things. Okay, next, so as a data source we can collect multiple data from multiple devices and some databases also, and some weather reports for real-time analysis. Once processed, the data is passed off to data sinks. So as I have told you that after analysis, once processed, the data is passed off to data sinks such as an application, data store or another stream processing engine. As I have told you that once the data is processed after stream processing engine stage, then we can store that output on any data sinks. Let us take it may be an application. Okay, so as a sink we can take an application or any data storage or any other stream processing engine as an input. Okay, so in these three stages stream processing model works. Now let's look at into further the data stream. Okay, what is the data stream? The data stream is a source of data. Here we can say data with a combination of continuous flow. So we can say that on the move, the data is on the move from the multiple sources of data is on the move. We can call it as a real-time continuous data with the programming languages, primitives and construct that allows us to express stream processing. So with the help of some programming languages and some other tools, we can analyze that continuous movement of data. The fundamental concepts of stream processing involves three steps. Okay, so what are those three steps? Just now I have explained you that those are nothing but data sources, where we can collect the data from multiple devices or multiple sources, and in the middle, stream processing pipeline, which works as a analysis engine, and next, as a result, we store a data sinks. So here you can see in this small diagram, this is a three-step process. Now let's move on to the individual terms. What is source and what is sink? Individually we'll analyze it. The concept of sources and sinks in a stream processing. So what are these two terms? What are these two terms involves? Data is consumed from a source. Okay, here we are telling that data is we are collecting from multiple sources by processing components, and eventual results are produced to a sink. So as the data is collected from sources, eventually those data are processed via some components and those are produced some outputs, those are stored on some sinks. The idea of sources and sinks represents the system's boundary. So we can say that from collecting sources, data from sources to storing data sinks, we can call it as a system boundary. Within this entire system, everything has involved. For example, it is possible to connect an Apache Spark cluster to another Apache Spark cluster or to another distributed system of Apache Kafka is a frequent example. Here, as I have told you that Apache Spark works in a distributed manner. Okay, one master system is controls all the other systems, right? So all these systems works in a distributed and parallel processing model. So if we connect multiple systems in the same manner, so there is a chance of one Apache Spark process, if it involves, so there is chance of working all the systems in a distributed manner, right? So we can say that data is passed through one system to another system, one system to another system in a sequential model, right? So we can say that clusters are interconnected by using Apache Spark model. In that context, one framework sink is the downstream framework's context. This chaining is commonly known as pipeline. So if all the clusters are interconnected like this, so one system's data sink can be another system's data source, right? So data is here from first system or first cluster, the output is going to another system as a data source, which means that one system's output is another system's input. So it follows in the same manner for all the systems if the systems are connected in a continuous cluster model. So that is nothing but this flow we can call it as a pipeline. Pipeline means how the general pipeline works, that flows the water, right? In the same manner all the systems works in a pipeline model. So next, stream processing framework. Okay, here streaming framework. What are the components involved in stream framework? We are going to look into it. So the streaming framework of Apache Spark uses the concept of streaming data sources. Here, as I have told you in the previous slide, it is nothing but it involves the data source first as a framework. In the context of stream processing, accessing data from a stream is often referred to as a consuming the stream. So here technically we can call it as a consuming the stream, which is nothing but data source. So here technically we can call data source as consuming the stream from multiple sources. This abstraction is presented as an interface that allows the implementation of instances aimed to connect to specific systems. Okay, so those systems are connected via this abstraction. Let us take an example: Apache Kafka, Flume, Twitter, a TCP socket, and so on. So here if we take an example, TCP socket. Okay, here TCP socket works as a data source. So directly from internet by using some TCP protocols, okay, through socket connection, we can generate the data in the form of text or any other file formats, and on the spot we can count the number of words, or we can implement the logic which we have generated by using the TCP protocol or TCP socket. Okay, and another example, if we take Twitter as an example, okay, lively we can collect the data from the Twitter account and we can analyze how much data is consumed by the users of Twitter and how many followers are involved in the Twitter. Everything we can count by using TCP by using analysis part. So likewise, we call the abstraction used to write the data stream outside of the Apache Spark's control a streaming sink. So after collecting the data and after collecting the output from the analysis, we can collect that data onto the sink, which is nothing but technically we can call it as data sink, which is nothing but streaming sink. So here we can say that data source connected to streaming engine and streaming engine connected to data sink. So all these three steps works one by one. So now let's move on to the next slide. So here again sources and sinks. Now we'll go deep with another integrated things. So Apache Spark is of its two streaming systems in structured streaming and Spark streaming. Especially by using Apache Spark, we can implement two types of streaming system. The first one is structured streaming. Second one is Spark streaming. These two are the models. Apache Spark provides us for analyzing big data in a real time. So is a programming frameworks with APIs in the Scala, Java, Python and R programming languages. So by using these all programming languages, we can integrate all the data sources and sinks by using some APIs. So here we can integrate all the programming languages to analyze the real-time data by using some APIs. So, and especially Apache Spark has developed initially with a Scala programming language, and we can integrate easily with the Java program as well. Okay, so we can call it as a Apache Spark. And if we integrate Spark with the Python program language, it is nothing but PySpark. Okay, it is called it as PySpark technology. Next, if we integrate Spark with Scala or Java programming language, then it is called as Apache Spark. Okay, technically it is nothing but Apache Spark. Here these two are connected in interrelated to each other. Okay, next, it can only operate on data that enters the runtime of programs using this framework. So this frameworks works as a integration between multiple technologies, and it ceases to operate on the data as it is being sent to another system. Once the system has sent data to another system, automatically it stops generating the data, or the data is seized on the first system. Why? Because already the data has passed through the first system. Okay, if the data or any output goes as an output or input to another systems, so the previous system's data has automatically ceases. So it can reduce the scope and it can reduce the storage as well. To operate on data stored as a file of records, we need to read that file into a memory. Okay, Apache Spark especially stores in-memory storage. Okay, it will use in-memory storage, which means that the data is stored on RAM. Okay, which is easy for us to store the data, collect the data and retrieve the data from RAM. Okay, and this may provide the faster efficiency. Okay, if we use RAM or memory as an input or output stream, it is easy for us to access the data in a faster pace. So where we can manipulate it, produce an output by computing on this data. We have the ability to write the result to another file. So at the last we have to write the output to another files. It may be one application, or it may be some databases, or this may be another devices. Okay, anything we can use as a data sink. Now let's move on to the next slide. So here we can see in this picture how the data source and data sinks collects the data from multiple sources. Here we can call data systems, APIs and files as a multiple data sources, which will comes into the data connectors, which will come into the data connectors. So and after that data is ingested directly into the stream pipeline. Here you can see in this diagram, these two are nothing but stream pipeline. So after getting data from the data sources, pipeline will execute the data and get the proper insights by using some technologies, and next data is stored on a sink connector. Okay, here the sink connector will store the data on again multiple sinks. Here we can use the same data sources as a data sinks, but here we are storing it as a sink, which means that we are storing the output after analysis. We are storing the output on the same devices, or here we are taking it as an input. Okay, we can say this is an input sources and this is an output sources. Okay, and in the middle there is a stream pipeline. We can call it as a stream pipeline. So in the 3-step model, stream processing programming model will works. Now let's move on to the second topic. So as a today's presentation, as a second topic, we are going to learn about immutable streams. Okay, immutable streams. Immutability is a fundamental concept in Spark design. Okay, first of all, before going into the topic, we'll learn about what is the immutability means. Okay, the word itself suggests that immutable, which means that which are unchanged. Okay, immutable means unchanged. So immutability is a fundamental concept in Spark design, ensuring that once a data structure like RDDs, data frames and data set is created, it cannot be modified. It cannot be modified. Here you can see as a data source in a Apache Spark, we are going to integrate with RDDs. RDD is nothing but resilient distributed data sets, or we can work with the data frames, and we are going to integrate with the data sets as a data sources. So these data sources, once the data is collected via these many structures, once the data is collected, we cannot modify it further. Okay, instead transformations on streams or other data structures results in the creation of the new objects. Once the transformation functions are applied on these data structures, so there is a chance of creating new object instead of changing the previous data, so leaving the original data unchanged. So here as a result we may get the original data as it is, and if we can ingest any new data into the data stream, so it will create new object instead of changing its existing data. We may get new objects. Next, so in the context of Spark streaming or structured streaming, so these two are the models in Apache Spark. The immutability principle applies as follows. So how this immutability concept works in these two streaming applications or streaming models. Now let's move on to the one by one each. So here in Spark streaming, first we'll look into Spark streaming. So in Spark streaming especially we use D-stream concept. D-stream is nothing but discrete streams. So in Spark streaming, a D-stream is a sequence of RDDs. Okay, D-stream is nothing but sequence of RDDs. Okay, sequence of RDDs. The entire RDDs are collectively called as D-streams, which means that discrete streams. Each RDD in the D stream is immutable. Okay, so we can say that each and every RDD is immutable, which means that once the RDD has created, we cannot change the RDD. We cannot change the content or data into that RDD. Any transformation applied to a D stream, example map or filter. As you know that transformation functions are map and filter. Okay, map and filter. If we apply those transformation functions on to each and every RDD, creates a new D stream without altering the original one. Okay, so here which means that if we apply transformation functions on existing RDDs, so automatically another D stream is going to created with the data, new objects. Okay, instead of changing the content or changing the RDDs, it will create a new RDD or new D stream. Collectively D stream it will create. So now let's move on to the structured streaming concept. Okay, then in structured streaming, operations on streaming data frames or data sets also follows immutability. Here structured streaming deals with the Spark SQL. Okay, structured streaming is a built on top of Spark SQL, right? So here in SQL the data is modeled as data frames. Okay, data is modeled as data frames. Okay, data frame is nothing but it is a combination of rows and columns. Okay, data frame is nothing but combination of rows and columns. Okay, we can say that it is a combination of rows and columns. So those are also once created, we cannot change the content. Transformations like select, filter or group by create a new data frame or data set rather than modifying the existing ones. So if we apply transformation functions like select, filter or group by to each and every rows and columns, those columns or rows are created with another data frame's address. Okay, with another data frame instead of changing the existing data. Okay, instead of changing the existing data, these data frames are created with new objects. This is the fundamental concept in Spark design. So now we'll go deep into the immutability. Okay, immutable streams defined from one another. Okay, how we can define immutability from one stream to another stream? Both APIs in Apache Spark take the approach of functional programming. Okay, especially Apache Sparks work with the functional APIs. API is nothing but application programming interface. They declare the transformations and aggregations. They operate on data streams, assuming that those streams are immutable. Once the data streams are declared, transformations or aggregations performed on those data streams, then we cannot change the stream another time because those are immutable. After applying the transformation functions also, we cannot change the data. In a given stream, it is impossible to mutate one or several elements. Okay, if we declare a stream, if suppose we declare a stream, one or multiple streams, once we declare those streams, it is impossible to change those streams second time. Instead of we can do that, we can create new objects. Okay, instead of creating or instead of changing the existing stream or multiple streams, we can create new streams with a new objects. So here we can say that immutability enables Spark to provide fault tolerance, which means that automatically if there are any errors or any mistakes happened by any devices, so we can collect the data by using the duplicate storing process, which is nothing but fault tolerance. Okay, once the data is created, the duplication of the data is stored with the master nodes, which we collect further. That is a functional and essential feature of Apache Spark. Since lost or damaged data can be recovered by rebuilding the lost RDD partition from the other. So here, suppose let us take an example. We have declared RDD1. So here this is RDD1 and RDD2. Suppose is any failure happen to the system, there may be chance of losing RDD1 data, right? So here if we create another time the RDD1, so it will recollect from the existing RDD. It will create a new RDD with the existing data. So here we can say that is a main basic thing of Apache Spark. So we can rebuild the lost RDD by RDD partitions by using already existing stream. Finally, RDD immutability is a key characteristics of Spark. So we can say that as a conclusion, RDD is a key characteristics of Apache Spark. So that immutability, its scalability, parallelism and fault tolerance. So RDDs are immutable and those are providing scalability, parallelism and fault tolerance to Apache Spark. So this is the key characteristics of Apache Spark via we can reach scalability, parallelism, and fault tolerance concepts by using RDDs. So this comes an end of my presentation. Thank you.